Hi, wish you good luck. I am Dr. Dharmaiah working as a professor in computer science engineering in our KL University. Today I am going to give topics related to our subject data driven artificial intelligence systems searching algorithms. In these searching algorithms, the following things are there: uninformed search algorithms, informed search algorithms, and in that informed search algorithms, best first search and heuristic functions are related to A star algorithm and local search hill climbing algorithm. These are the topics we are going to discuss in this session. Okay, generally, what is a search? Okay, in this essence of the search, if you want to locate any item or any state or any node, in this case we are finding out the infinite number of states where it is there. In that connection, here we are searching the elements through the trees or through the graphs or like that. In that case, we have infinite number of paths and states and so on. Okay, in this way, here we are going to use a tree node structure and with having different siblings. So, for example, in this graph, okay, we are going to deal with for example, if you are look at this is a start. After this, here set the initial value. Okay, that is called that is called our starting point, and after that, here we are getting the initial state, goal state, what is the goal state and so on, expanding using our algorithm related to suppose whether it is going to next state or not, or check the whether the best state or not, and then set the new state. If it is the best state, modify the best state, and like that it will be. If it is in a goal state, after verifying if it is an S, okay, stop the process. This is the way search process in general phenomena. Same logic we are using in different fashionate. Okay, and here the choice of states, what is then a search strategy? Okay, that means what is the choice, how we can go to search algorithms. Okay, before going to search, okay, here there are measuring problem statement performance. There are here 10 parameters are there: completeness and optimality, time complexity and space complexity, and path cost, search space size, number of states explorer, heuristic evaluation, search path length, and search depth or breadth, like that. Okay, now what is meant in a completeness? In this completeness, the algorithm is guaranteed to give the solution or not, that is called completeness. And optimality, whenever we are find the optimal solution, that is called best solution, that is called an optimal. And time complexity means how much time it will take to find a solution, that is called time complexity. And then space complexity, okay, what are the how much memory it will be required to execute the program. And path cost, okay, what is the cost, okay, path cost, how much nodes will be delivered, and when initial state to the goal state and so on. Search space size, okay, here the search space size is nothing but how many nodes are there in that case, and the number of states, okay, whether the number of states are occurred, okay, what is in a tree, what are the nodes and different, and heuristic evaluation also, this may be a best example for us. And then search path length, what is the number of length are involved, how many nodes are involved in that, whether we are going for search in a depth or breadth, okay, it is a side by side or in the level by level, okay, these are all 10 performance measurements when we are going for a search. Generally, here search techniques are divided into two parts now: uninformed search and informed search. In informed search, the following algorithms are there: best breadth first search, depth first search, and depth limited search, iterative depending on search, bidirectional search. Okay, these are all the algorithms are there. In whereas in a second category, informed search, okay, here best search, best first search, and then next one is greedy search, and then introduction to BFS, and what is an A star algorithm, what are the different A star algorithms or hill climbing. Okay, in our syllabus we have only 3 components: best first search and A star and hill climbing search. These are all the only algorithms related to us. And then local search, okay, here so many local search are there, but in our syllabus we are focusing on only hill climbing, and simulated annealing and local beam search or genetic algorithms, local search in continuous, these are not there in our syllabus. Only the hill climbing we are going to go move in a search. Then adversarial search, okay, these are all the algorithms: alpha beta pruning, min max, and iterative depending on the combination of breadth first search and depth first search, and moto correlatory search. Okay, in this alpha beta pruning and min max are very, very important. And constraint satisfaction is also under the category of this, that is called backtracking search, forward technique, and constraint propagation, and heuristic search and local search. These are all different techniques we are going to use in this one. And then what about mean uninformed search? Okay, that is in a first category whenever we are dealing with. Here in this session we will discuss the several strategies. That means informed search. Okay, informed search we can categorize, it is in a blind search only, it is not more than that. Okay, that means it is a starting point and ending point, that is a goal state. In this strategy no additional information is required, about the states, but we know that starting point, what are its generate and successors and so on, and its successor to reach to the goal state. And all the such strategies are discussed in order which are expanded. Okay, like this is an introduction. So for example, what is a solution, what is a search tree? Okay, that means what is a solution? If a solution is getting from starting point to ending point, that is an initial state to the goal state, okay, our problem is solved. In this case, tree search, okay, how the tree will be starting? A tree is having a root node, okay, like this, and then initial state, that is called, we can say that root node, and after traveling root node to the branches, okay, whether it is expanding, that may be, yeah, you see here it looks like a tree. Okay, here an arad and arad, okay, like that, Tomishi or Jira and like that. Here this is called a level 0, level 1, level 2, like that. So many levels are available in this. This is a way we are going. Whether we are going to the left side or right side, whatever it is, based on the cost minimal path. Now, for example, in this case, okay, in this representation of node, how we can search? That's why here we have an state, parent, action, path, and depth. These are all the belongs to technical terms. Okay, what is a state? A state belongs to a space, state space, and a node belongs to a state, that is called a state. Parent is the generating node to the children's, that is called parent. And action, what is a parent node to generating, that is called action. What is a path cost? What is the cost of g of n? Okay, the from initial state to the node, the best node from the point starting point, that is called parent point, that is called a cost path. And depth means n number of steps we are going to initial state to the n number of levels. Okay, these are the representation nodes we are using while we are coming back to this one. And here there is a node and states. Okay, these are all the technical terms we can use in the different way. So for example, in this case here, a node is there, here the parent and a node generating, and here there is an action like this. Okay, what is an action? That is a write cost. Okay, these costs are represented using this table, so that we can bookkeeping array point from the where it's starting, what are the cost and how it will be generating next node. This is some basic terminology. Okay, in this case actually we have informed search. The following things are there. Okay, that means informed search, that means the techniques: best first search, the first one; second one depth first search, this is called BFS, and second one is in a DFS, and the third one is depth limited search, and iterative defining depth first search, uniform cost search, bidirectional search. These are all I am going to give you first two. Okay, that means here these two. the best first search and depth first search I am going to evaluate in this session, okay, within a brief and the remaining are some little bit examples. So, for example, let us say here there is called a breadth first search. What it mean? Here breadth first search is related to a graph. Okay, first it will be related in a graph, and this algorithm search the breadth wise to a tree or graph, and along with an initial state to the goal state. Okay, BFS starts searching from root node to the expanding of all the successor nodes, and it is the next level. And breadth first search is a graph related algorithm, and it is more related to FIFO, that is called queues. This is an overlook of this breadth first search. Okay, here there are advantages and disadvantages are there, that is called pros and cons. BFS will provide a solution if any solution exists, and if there is more than one solution for a given problem, BFS will provide minimal solution of that one, least number of steps. That is why this is a least number of steps and minimal solution, that is why it is a good one. And next, whereas disadvantages, it requires lot of memory, okay, that is a drawback, and it requires lot of time also, okay, that is why this is a BFS. And then here this is an example. Now look at here, we have a tree like this, okay, S is a root node and it has two siblings A and B. Again A is a root acting as a root and it has two siblings C and D. B is a root, it has some G and H like this. Okay, here where is it starts from the root by using this arrow, and after this it starts from the one node, it is the same level traversing, and again it come back to the next node and the same level, okay, like this. See the graph, okay, the path which exactly going to this, like this is the way traveling, this is called a breadth first search. Okay, we are starting from the level 0 and level 1 complete all the elements, and after that only we can go ahead in the level 2, and after the level 2 all elements are visited, then only we can go to level 3 and so on up to n level. Okay, here the 4 levels are there. This is called an example of breadth first search. And then next, what is a time complexity? The breadth first search, the time complexity is order of b power d, that is b is in a breadth, d means in a depth. Okay, d is nothing but a depth, b is nothing but a breadth, and if the space complexity is this one, order of b power d, both are similar, and the completeness, it will find the solution if it is a goal state and a finite depth. That is why it is a best completeness, and optimality, it is also giving a non-decreasing function, okay, that is a non-decreasing function, that is a uniform search algorithm. And then next second one, okay, depth first search. In the depth first search is a recursive function, and it is also looks like but BFS, but it go for depth wise, or after that it visit the nodes, and DFS uses an stacks. Okay, here stacks, that is a stack data structure, but whereas in BFS uses in queues, but here it is used in a stack. And DFS algorithm is similar to a BFS, okay, that is a more or less similar, but only thing is backtracking is an algorithm technique to find all possible solution in recursion. It will be used in depth first search, DFS. Okay, here so many advantages are there. Here DFS requires very less memory, whenever BFS requires more memory, you know, we talk about that is a reason, but it is covers like that. It takes less time, same in BFS it takes more time, but in this DFS it takes less time. And here also there are two disadvantages. It possibility of time taking to reoccurring the state, there is no guarantee to find the solution. Okay, there is no guarantee to find solution, but whereas BFS we can get it, but even the more time. Okay, DFS algorithms is deep with an infinite number of loops. Okay, that is why it is not used in an infinite number of loops. That is why we are discuss this one. Now, how it is works? See here the graph. Here DFS search is coming from the S root node to the next level, depth again next level and next level. After this, it will visiting the nearby next level, and then here next level. Okay. Sorry, here next level and so on here, and next like this. This is the way to visiting, like 0 level, 1 level, 2 level, 3 level, then only I am visiting, But whereas in BFS, okay, see here the BFS is root this is an way, but whereas in a DFS this is called BFS, and whereas in DFS, okay, that means it's going but next level and next level, like that it visit that depth, it will be travels. And then what are the these depth per search completeness and time complexity? See here, depth per search time complexity is the order of n power m, and here space complexity is order of b power m. And then next here next one is, next algorithms are I am going to only the diagram. This is called depth limited search. What is the depth? Suppose for example in the DFS, okay, we can go ahead and enter n depth. Here suppose for example I can say that only the two depth, okay, like that 1 and 2, then only you can visit the next nearby one. This is the depth. So for example in this case in the depth limited is 3, 1, 2, 3 and so on, like that. This is a depth limited search. This is an example. And one more newer one, uniform cost search. Okay, here a tree is having a cost like 1, 2, 3, 4 and so on, some each and every node, and along with an edges is a cost 1, 2, 4 like this. If the cost is always selecting minimal cost, unicorn, okay, that means, and then next here is select the cost, okay, 2, then 3, like that. This is a minimal cost 1, 2, 3, there are lower values, so that the goal state to the final state. This is one of the example. And then next another one is iterative depending on depth first search. Here see this iterative means here same tree level 0, level 1 and so on, level 3 we have. Okay, in the first iteration it select only A, that is why here it written A. In second iteration ABC, see here this is our second iteration, that is why ABC. In third iteration, see here ABC along with this one, whole things will be covering. And in the fourth iteration, okay, that means all everything will be covering. This is the called iterative depending on depth first search. And then next here lastly we can dealing with a bidirectional search. Okay, actually in the searching mechanism I told you in the beginning of this one session. Okay, in this case we are starting with a root node, and after that next best node and so on, next goal node. But here starting to goal node reaching we are taking more time, that is why in the bidirectional search parallelly it starts with the root node and goal node, and slowly it will be starting from here and here, and slowly it will be meet at the midpoint. This midpoint is getting a best solution for us. This is these are all algorithms we are dealing with in a uninformed search and category. Suppose for example informed search algorithms, what we have to do? Okay, in the informed search means uninformed means there is no that is in a blind search, but here it used some techniques. It is informed search is a knowledge it will be taking. What is a knowledge, and what is a goal state, and then what is a path cost, and how to reach the goal state and so on. This knowledge will be help to the agents to explore the lesser the search and find the efficient goal node. Okay, and the informed search is more useful for large space. Okay, whereas in NQ's problems and so on, even it may be dynamic search algorithms we can use, and here it will be used working with a heuristic function. Okay, heuristic search. Okay, that is why we are using a heuristic, always using a best solutions. Okay, here the prior knowledge, that is what are the nodes are used in this case and so on. Okay, here in this heuristic search techniques, so many algorithms are there. That is called best search algorithm, greedy best search, and informed best search, A star, AO star, memory bounded A, and then here so many variants of A's. There are 8 variants are there, that is called weighted A star and weighted A star, adaptive A star, anytime repairing A star, real time adaptive A star, simplified memory A star, and hierarchical A star, and life planning A star, like that, iterative defining A star. But these are all not there in our syllabus. We are focusing on only the 3 elements, that is called BFS, and A star, and next component is hill climbing in this case. Okay, here heuristic search. Okay, what it mean heuristic function, how it is really dealing with in uninformed search. Okay, actually the cost occurred to reach the goal state is not considered, but no account is there. But whereas here you can take the heuristic function that is called an h of n and estimate the cost. Okay, estimates the cost to be occurred within a goal state or not. Okay, here we are verifying, and this h of n is an underestimated, it is less than or equal. Okay, here we are going to deal this one, our lowest cost which will produce to reach the goal state. Okay, to reach the goal state, in that case we are using this heuristic search techniques. Actually heuristic functions are having two types, that is called, the first one is admissible heuristic function and then constant or monotonic heuristic function. What is an admissible heuristic function? If h of n, okay, we can define a function h of n, it should be an admissible. Okay, here that is called h of n value is less than or equal to the true cost of the goal node. Okay, that is a function, that is called, see here, less than or equal, this is a main essence. But whereas we can go ahead with a constant or monotonic heuristic function, okay, here that is called the h of n, okay, is a greater than or equal. Okay, that is the only the difference, greater than or equal to estimate from the goal state. Okay, here the final objective is you have to reach the initial state to the goal state. In that case we are going to deal with this one. Okay, here so many heuristic functions are there, and here by using the following techniques, that is called Euclidean distance. Okay, Euclidean distance means the current what are the two nodes will be distance between that. Okay, by using a formula, Manhattan distance, air distance, graph distance, max heuristic function, and pattern databases, and these are all we are using in this case. Now we can highlight with what do you mean Euclidean distance function. So for example, let us say here Euclidean distance function is, okay, here this is an one point and this is also one point. For example, we have 1 or 2 points are there. Here the what is the distance between P1 and P2? Okay, this point is x coordinate and y coordinate, this point is also x and y coordinate. Okay, here the distance between these two is P1 and P2 square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, this is a standard formula. Based on this formula, what is the distance of that? Diagonally we can take these values also. So for example, whereas this is this diagonal is nothing but an Euclidean distance. So for example, we can travel this is a distance for Manhattan distance. Okay, these are all the remaining. And then next the first one is in this informed search, best first search. Okay, here the best first search algorithm is always used an evaluation function. That function we can call it as a heuristic function. And in this it will be evaluated. Best first search is it is guided by heuristic function. Always heuristic function is select the minimal cost. Okay, lower heuristic values will be select the exploring to reach the goal state, from the initial state to the goal state. That is why it is always the best. So for example, let us say here we have a minimal path cost 2, 4, 5 for example. In this case 2, 4, 4, which is the best one? The lowest value is 2. Okay, that is why we are pick up the 2. So for example, the next time 10, 20 and 30 we have. For example, in this case we have only the 10 is the best one, lowest value. Okay, based on that consideration, that means let us say here consider these all three are heuristic function values, these all three are heuristic function values, but minimal cost best solution it will be find out. Okay, this is an algorithm for best first search, step by step algorithm. Okay, here the create an empty queue, that is step 1, and then next create an empty stack, and is then step 2, and then third one is while priority queue is not empty, remove the node with the highest priority and remove the node with a goal node and return the path and so on, start it to the solution and remove the node and so on. And finally there is no solution, the goal state is not found prior to Q, you put an empty, otherwise you can put in a general steps. These are all internal steps calculating best solution. Okay, in the best first search algorithm produces step by step by using what we discussed in previous pseudocode. Okay, this is another pseudocode for based on this algorithm. Okay, the function how we can write in a code in any language, but here there are methods we are going to give you a solution. Okay, in this case best first search, here the starting point and goal point and heuristic function, how we can evaluate that is a starting point and heuristic functions, and it will be giving a best values for us. For example, here the performance analysis, what is the performance evaluation, how to evaluate best first search performance analysis means it depends on quality of the heuristic function, perform the well is the admissible heuristic function or not, and what is the memory, how much memory it is consumed, what is the defining number of nodes are expanded, what is an optimality solution of this one, okay, what is the longer path of this one, like that here we are evaluating all this. Okay, here this best first search advantages, so many are there. It is an efficient one, best reaching the goal, and it is also used in a guided explanation, and best one is to find the optimal solution. There is a guarantee we can get the solution optimality. And then in this after end of this session, we are going to use in this searching technique, searching algorithms, uninformed search algorithms, and then informed search algorithms, and best first search. We are discussed all these things now this session. Next session we are going to discuss with A star and hill climbing algorithms with in details with the next session. Thank you.